Hi, today we're looking at fractions, and I've titled this No, Not Fractions, because so many people have trouble with fractions. So if you do, you're not alone. And I'm wondering if the reason for that is that they're pretty complicated and they're taught when people are really young, maybe too young to learn something that complicated, but you're not a kid anymore. You can absolutely do fractions. So we're going to start with multiplying fractions. So I made a sample problem here. It's 21/16 times 24/49, and I'm using the dot for the multiply sign because when we start using x's as variables, it gets confusing if you use x for a multiply sign. So we're using the dot to mean multiply. So the first thing you need to do when you're multiplying fractions is to break down the numbers into the smallest pieces you can. So 21 is 3 times 7, and you can't break 3 or 7 down any further. So that one's done. 16 is 2 times 2 times 2 times 2. And 24 is 2 times 2 times 2 times 3. And 49 is 7 times 7. So we broke those four numbers down as far as we could. Now, when we're multiplying, we can multiply things in any order. So I just moved them so they were all going from lowest to largest. You can skip this step if you want to, that's fine. I think it just makes it a little easier to see what's going on. So I wrote them from lowest to largest, and then I broke those into any ones I had. One being something divided by itself. So 2 halves of a pizza is 1 pizza. So 2 over 2 equals 1. So we end up with 2 over 2 times 2 over 2 times 2 over 2 times 3 divided by 2 times 7. Those didn't have anything to match them up with. And then a 7 times 7 at the end. And since one of anything is that thing, you can get rid of the ones. So the example I use on the slide is 1 George is George. And that kind of works in math. So anytime you have a 1 of anything, you just can leave the 1 off. So we end up with just the things that didn't turn into a 1, which is 3 times 3 over 2 times 7, which is 9/14. So most people learn how to multiply the numbers together and then simplify, but that's so much harder. So if you multiply 21 times 24, you get 504, and 16 times 49 is 784. That's a kind of a mess to simplify, and you end up breaking those down into the very same numbers we broke them into, just starting at a much harder level. So I recommend just breaking them down from the very beginning. Now we're going to subtract fractions. So our sample problem is 9/8 minus 5/6. And this time we're starting by finding a common denominator. So we only need to break down the bottoms of the fractions, but we break them down just like we did in multiplying. So 8 equals 2 times 2 times 2, and 6 equals 2 times 3. So we need a common denominator. That means the number and bottom of both fractions has to be the same before we can subtract. We're just going to ignore the tops completely for a little while. So we look to see what's missing. If you look at that first fraction, it's 2 times 2 times 2. The second one has a 2 times 3, so the first one needs to get a 3 if they're ever going to match. So we're going to need to multiply by 3 over 3 to get that 3 in the bottom. And we can't just multiply by a 3 in the bottom because then we're changing the problem. But if we multiply by 3 divided by 3, or 3/3, we're multiplying by 1. And that doesn't change the problem at all, so completely legal. So we multiply the first fraction by 3 over 3, and then we look at the second fraction to see what it's missing. It has 1 2, but the first fraction has 3 2's. So it needs 2 more 2's, And so we're going to multiply by 2 times 2 divided by 2 times 2, which again is 1. So we have that set up near the bottom of the page, and then you just go ahead, once you've got the same numbers, 2 times 2 times 2 times 3 in the first fraction, and 2 times 3 times 2 times 2 in the second fraction. Again, since everything's multiplied, we can do it in any order, so those are the same. And then we just multiply the top, 9 times 3, which is 27, 5 times 4, which is 20, and now we can subtract because the bottoms are the same, and we end up with the answer of 7/24. So hopefully you can pause. I know it's a little hard with these slides, but go ahead and pause and work through it till you understand it. And hopefully that canceling words makes math kind of seems like magic instead of something that makes sense. Hopefully going through it this way, it's finally going to make sense instead of just magically canceling things because you can. So have a great week. Thanks. Bye.